Yeah, sure. This Ziggs will be there. A pointer to a U8 hurts my soul. It should. All right, U8D's nuts. Okay, got him. Let's see the Zig League section. Yes, it's going to be on YouTube. I'll put this on YouTube. It should be a okay. So it's an undefined slice, is what you're trying to say. It's an unknown. What you're trying to say is this one right here, which is a too many item pointer, an array of unknown size. Right. It's a potentially null array of unknown size. Yeah, see, I'm not getting it yet. We haven't got it yet. We're just not, this is not it. Okay, let me look at this again. Okay, so I get this part, but what I don't get is this. Okay, so let's just see if we can do this one. If this exists right here, why can't I take this? Why can't I take this and do the exact same thing, right? Why can't I just do that? Nice, I got it. I got it. I got it. I got it. We got it. I so got that one. Okay. Okay, so that's what it is. Pointers, baby. Starbucks languages. This is actually a morally abhorrent language that we're learning right now. An array of an unusual size. I don't think they exist. An array of unusual size. They do. So there you go. Okay, so this makes sense. So I'm taking a letter, I'm taking a reference to this thing, and then actually treating it as a U8 array of size 1 that's a constant pointer to it, or a set of constant values of size 1. Okay, this makes sense. Is wild syntax? It's not too wild, because this right here means that it could be null. This right here means that it's a pointer. This is just its constant values of size 1 U8, right? To me, this doesn't bother me, right? That is a single item pointer to an array, which is not what people expect. Yeah, I mean, it's technically the same thing, right? If you think about it, this is an array of size 1. Everything is an array if you really think about it. If you really think about it, everything is technically an array. Okay. Yeah, but can it be null? Yes, it can be null. So I can then also take this and go like this. If I do this correctly, I believe I can just take this out and say null. There we go. It's null. Because I specified the type as being potentially nullable. So for me to be able to get the letter out, I believe I have to go like this, right? Did I get this correct where you have to go my letter, letter, right? To get it out, right? Did I do that correct? Capture letter shallow local constants from outer scope. Oh, whoopsies. L. There you go. So now I've now got the value back out. Or you could do what it does down here, which is this right here, which is period question, which says like, let's force it to be not null. Which if I'm not mistaken, I'm pretty sure this will actually cause a runtime explodey. Oopsies, you can't assign it to const. Yeah, that makes sense. Right. Pass, letter A. Oh, whoopsies. There we go. There we go. Terminated unexpectedly. Yeah, I've effectively crashed my program. It's suppressing output, but I've crashed the program because this is an asserts not equal. I don't like type inference. I like type inference when it's good. Period question is called the Elvis notation, right? Is it? Is that Elvis notation? I always forget which one's the Elvis one. In debug and safe let's see. In debug and safe not release modes. In release modes, it's undefined behavior. Okay. Okay, well, cool. Anyways, let's go on then. I do like that that the language enforces you to make things that don't change constant. All right, here we go. Loop expressions. So let's do some loop expressions. 62. What else can we do here? Remember, using an if-else statements as expressions like this. By the way, for everyone that's wondering, Carson Gross, HTMX guy, will be here in approximately 28 minutes. So we're just passing some time with a little bit of zigging. Yeah, double question is Elvis. Okay, double question is Elvis. Are you sure? Zig also lets you use for and while loops as expressions. Like return for functions, you can also return a value from a loop block. Break true. Okay, Rust has the same thing. Cool. But what value is returned from a loop if a break statement is never reached? We need a default expression. Thankfully, Zig loops have an else clause. Okay. I think that could be really cool. And as you might guess, the else clause is evaluated when, 1, a while loop condition becomes false, or 2, when a for loop runs out of items. So you can go while true, break 2, else 0. For this U8 of 1, F, break 3, else 0. Nice. Nice. If you do not provide an else clause, an empty one will be provided for you, which will evaluate to the void type, which is probably not what you want. So consider the else clause essential when using loops as expressions. For while true, this is an error because the implicit void right here. Okay, that makes sense because you don't know, because you can't guarantee that the while loop is going to return something. I assume that's the reason why. That's pretty neat. I like it. With a program in mind, let's see if you can fix the problem. Okay, let's see. We got languages. We got Erlang, Algo, C, OCaml, Zig, Prolog. Let's find the first language with the 3-letter name and return it from the loop. All right. So current language is a nullable one of these. For langs, do this. Else null. Is it break null? Or is it just null? What's the syntax here? Else 0. Okay, else 0. Okay, I like that. Else 0. I'm a fan of that. I'm a fan of that. Okay, current lang, do this one. We did not find one. Okay, so I should be able to Zig build. Yeah, awesome. We got that. Okay. Labels 63. Labels should be easy. Yeah, you have outer block, inner block, unreachable. Okay. Inner block, break to outer block. Okay, this all makes sense. Make 5. Constant foo, make 5, break to the... Oh, interesting. So you can even break... Oh, you can break out of a scope. That's like goto. You can break out of a scope and return a value. Okay. Okay. Hidden goto. Yeah, Rust can too. Rust, you can break out of a scope and return? I didn't know that in Rust you could do that. Where do I find this? This is just Ziglings. Labels can be used with loops, being one able to break out of the nested loops. Yeah. So you can do var loop. Oh, okay, nice. That makes sense. Okay, perfect. I think I get this. Continue. Finally, you can use a block labels with continue statements. Okay, cool. So let's fix this right here. So we have a print statement, we have our print statement, we have our ingredients. As mentioned before, we'll soon understand why these two numbers don't need explicit types. Food is a struct with a name and required ingredients. Bool. Oh, that's because this just gets evaluated to a number. The compiler just turns that into a number. Okay, cool. Okay. Welcome to the Cafeteria USA. Choose your favorite ingredients and we'll produce a delicious meal. Cafeteria customers note, not all ingredient combinations make a meal. The default meal is macaroni and cheese. Software developer note, hard coding the ingredient numbers based on the array position will be fine for our tiny example, but it would be our downright criminal in a real application. It would be. Wanted ingredients. Okay, meal loop. All right, let's look at this. So we have our food loop. So somewhere in here we need our food loop to run. This ingredient isn't required, so skip it. Okay. Found our wanted ingredient. If we haven't found it, continue the food loop, which goes back up here. All right. If we get this far, the required ingredient we all wanted for, let's see, if we get, please return this food from the loop. Okay, so I would have to return, wait, hold on. What am I returning? What am I returning here? Oh, I'm returning food. So I just returned food right here, huh? Right? So the meal would be let's see. The meal is this. Okay, so that means the meal right now, what is the meal? It's that thing. So that means I can go like this. I can hit him with an else. I needed like a default meal? Oh, the default meal. The default meal is mac and cheese, right? Yeah. The default meal is macaroni and cheese. Okay, so that's menu 0, right? Ah, there we go. So I'd go menu 0, correct? I think that's correct. I think I got that. There we go. Forgot to label the break. I don't think I needed to label the break because the break is in this loop, so you don't need to do that. Did work without. Yeah, you didn't need to because it's already in the outer loop. Good morning, Primogen. You suck. Hey, good morning to you, Mod. You also happen to suck. All right. The following, okay, so we have some errors here. Okay, we can definitely do that. The Zig compiler provides built-in functions. You've already gotten used to seeing import at the top of every Zigling's exercise. We can also see int cast. Okay, yep, I remember int cast. And init from enum. I never actually used int from enum. Well, I guess I did, but I must have forgot about it. You suck. Hey, thank you, Mod. Wow, multiple mods. He woke up and chose to be violent. Yeah, classic Beastco. Just the man can't stop it. I thought Zig is an IDE. No. That's Zed. Zed would be the thing you're looking for. All right. So we have our print statement. We have our main. Let's see. The second built-in alphabetically is add with overflow. A, B, struct type of B, A, U1. It's kind of interesting that they have this any type right here. I wonder how this works because I don't know how to program that. This is a pretty interesting concept, though, that they have this. Right? There's some good stuff going on right here. All right, so we have this binary. We're going to add with overflow. These are U4, so they're a nibble. If we add with overflow, what does overflow do? Let's see, add with overflow returns the value as a tuple with the result and the possible overflow bit. Oh. It sucks that I really hate. I think the Zig language server is really just painful. Right. For me, that's the thing that I really dislike. Like this add with the overflow is not coming back with a result I know how to work with. Because I don't know how to work with the result. I don't. Is it zeros? What is this type? I don't know what the type is. It's unknown. I find that to be really painful. So let's see. What do we got here? I still don't know what these little anonymous function or these anonymous structs are or whatever you call them. I still don't quite understand them. So AB, my result. If my result 1 equals 1, true, false. Oh, I see. Okay. Inferred struct, yeah. ZLS decided to not use the existing rug compiler infrastructure, which was a huge mistake. See, I didn't know that. All I know is ZLS is definitely... I
love you.
It's definitely really lagging behind. Isa tuple. Well, it's... Yeah, but still, it's just like I wish I saw a tuple int, right? Or whatever it is. Instead, I have no idea what it is. Purple Moist Duck, thank you for that Twitch Prime. The catch syntax. Oh, I missed it. The catch. Let's see the catch syntax. Next time he'll write Twitch plays Doom. Yeah, I'm pretty excited about. I'm not gonna do Twitch plays Doom. I'm gonna do a tower defense. That's what I want to do with Zig. If I find the language server too painful, I think I'll abandon Zig until they improve it. Right.
Welcome to Costco.
And so, hey, Voltkin, appreciate that tier 1. Thank you. It's an any type. There's no way to specify a generic tuple. Okay, Crash of Clans and Zig. Well, I mean, it knows. The thing is that it knows this type. It knows this type. It knows these two types. So what should come out is a type that's probably very resembling that. Plus, it also what comes out here is going to be a tuple, one with an overflow bit. So it's going to be like a U1. Right? Have you seen the Google leak? It doesn't seem like it's a real story. Like, when I say real stories, it doesn't really seem like there's much to even say about it. Like, it have to compile. ZLS does not, yeah. What's your feelings on Zig right now? I don't have a strong feeling yet. All right, so let's make sense of the answer. If value B is decimal 5, let's add 5 to A. I already know what goes on here. This makes sense. Let's see. If there was no overflow at all, adding 5 to A, what would the value of my result hold? Oh, interesting. I'd have to look at the maths. I believe it just overflows, and then it keeps on going to this right here. Is that true? The real answer is 10, yes. So therefore, we'd have a false. We'd have this. Is this what it'd do? I think it's 2. Is that what it is? Here, what are the two numbers? The two numbers are, what is this? That's going to have a 1 right here. Yeah, and then this will overflow all the way over here, which will overflow. So yeah, it is just 2. Okay. It's just a 2. Fantastic. Bit reverse. Oh, cool. Look at that. There's a bit reverse in here. That's pretty neat. By the way, LibreVox, appreciate the tier 1 6 months in advance. Thank you. Let's go. And major sabotage. The answer is 14. It's always been. What is this? This is Zig. But this is cool. Bit reverse, so it flips the bits. I'm trying to think of how I would do that in Bitwise operations. How would you do that in Bitwise operations?
Welcome to Costco. I love you.
I think I know how. Hold on. No, you can't shift it. Shift is not the answer. So in Bitwise operations, so it's 1 1 1 1 1 0 0 0 0 0. All right, for this answer, the answer is pretty obvious. The answer would be, let's call this thing X, right? The answer would be X minus 1 ORed with, all right, it's just X minus 1. Yeah, it's just X minus 1. Hold on, it's X minus 1 with X XORed with X. No, there's something else in here. I'm missing one thing because I'm trying to figure out how to turn off that one. How do we turn off the rightmost bit? I mean, I know I could use Hacker Delight to grab that one. How would I grab this? I'm missing. So this is just 0, by the way. But okay, so X minus 1 would produce 1 1 1 1 0 1 1 1 1 1. Let's do another value. Let's go 1 0 1 0. So if I minus a 1 here, that would only take care of this bit. Okay, so minusing 1 doesn't really matter. How would I do that? I have no idea. Oh, of course. Duh, the logical not. What the hell am I saying? Have I been smoking? Have I just been smoking right now? Am I just dumb? That would just do that. So why can't, are there no, oh, this is bit reverse? Wait, why is that just not a logical not? Oh, it reverses them. Oh. Yeah, I have no clue. I have no clue how to do that. Yes, you really are dumb. I'm dumb. I really miss the old Primogen when when his freehand drew boxes instead of using the line. Okay, shut up. I do a lot of very beautiful drawing. Okay, that is a pretty good box. Is it going? I don't know. All the built-ins. Oh, that's nice. Documentation, master all the built-ins. You need to break the binary into blocks of this. Oh, dang, yeah. Okay, that seems crazy. Okay, yeah, I couldn't do that. I don't know how to do that, but found 2. I don't know why would you do that? Furthermore, here's a fun one. An integer value to reverse, return the value. Dude, I couldn't do that. I actually can't reverse. I don't know how to reverse one. Now it's your turn. See if you can fix this attempt to use a built-in to reverse the bits. But the built-in only takes 1 argument, right? Did I really fix anything? Hold on. Expected output is this one equals true without overflow. Oh, it went with a U8? Oh, the expected result as a U8. Oh, shoot. Okay, yeah. Well, then that would just be what are you? That would be a 1 right here and a 1 right here. Okay. Well, that's kind of stupid. All right. All I don't think there's a clean logic way. You can use the lookup tables. Yeah, I know. The real HTMX. Hey, by the way, real HTMX, you're here. Do you wanna just start now? You wanna just start now? I'm not even sure what that means. Keep grinding. Okay. 10:30. 10:30. Okay. Yeah. We'll go to 10:30. All right. Built-in's number 2. Let's do another built-in. 65. Zig has a built-in for mathematical operations such as squirt, sin, cos, exponential, log, floor. Let's see. It has lots of casting operations as error from int, float from int, pointer from int from pointer, int from enum. Spending part of a rainy day skimming through the complete list of built-ins in the official Zig documentation wouldn't be a bad use of your time. There's some seriously cool features there. Check out call, compile log, embed file, source. Okay, that's good to know. Now we're going to complete examination. Let's see. Now we're going to complete our examination of built-ins by exploring 3 of Zig's many introspection abilities. This type returns the innermost struct enum or union that is a function call is inside. Okay. Type info comp time t import standard line built-up type. Okay, which returns information about the type in the data structure, which will contain different information depending on which type you're examining. Type of type returns a type common to all input parameters, each of which may be an expression. The type is resolved using the same pure type resolution process the compiler itself uses when inferring types. Okay, I think it has me. You're broken the squirt for me. Oh yeah, squirt. Yeah, this is squirt. You know, a lot of people get this wrong. They call it square root, but it's never been square root. It's squirt. It's always been squirt. It's going to continue to be squirt. Squirty. It's not squirty because there's no Y. It's just squirt. It's just simply squirt. All right, anyways, let's look at this. Narcissus, me, myself, that, fetch the most beautiful type, this. That's pretty funny. All right. Oops, we cannot leave me and myself fields undefined. Please set them. All right, so me, myself. I mean, that's... Hold on. All right, I thought my cursor got moved. Here we go. Determines the pure type for the 3 separate types. Reference. They just happen to all be the same object. Type of this. What is the pure type? What is the pure type? What is the pure type of something like this? That's a confusing statement because it's like what is the type of something? What is the type of multiple things coming out? The pure type. Oh wait, pure type is the type in which they all eventually are. Returns the common type to all input parameters. Okay, there you go. It's the common type, which in this case happens to be a narcissus, right? Oh dear, we seem to have done something wrong when calling this function. We called it as a method, which would work if it had a self parameter, but it doesn't. See above. Fix this very subtle, but it makes a big difference. Okay. How do I do that? We don't really talk about that. All right, hold on. Oh dear, we seem to have done something wrong when calling this function. We called it as a method, which would work if we had a self parameter, but it doesn't. See above. To fix this very subtle. Is very subtle.
Welcome to
but
Costco.
It makes a big difference. So my assumption is it'd be a. If it's not there, it'd be this, which seems to work right there. Okay, it's just off there. Okay. I wasn't sure if they were asking me to put in the self. I'm trying to follow, but I'm lost. Let's see, use the type, not the instance. Is it asking? I'm not sure. So I just did this, right? So I'm just using the struct as the reference, right? Because it looks like a struct hanging function. His final words as he was looking in those waters he habitually watched were, "Alas, my beloved boy, in vain. The place gave every word back. In reply, he cried, farewell, and it echoed, farewell. Ovid, the Metamorphosis, translated by Ian Johnson. I don't even know what that is. He has room in his heart for... I don't even get that. What is this? Am I supposed to, like... What am I even supposed to put here? Is it chat? He can concentrate with all the chat? I'm trying to. I think it's poetry. Yeah, but the confusing part is, what am I supposed to put in here? Am I supposed to put something in here? Because now I'm just going to go like this and let it run. And then all right, here, let me fix the error, and then I guess I'll just figure out what I'm supposed to put. Yeah, I'm not a fan of those kind of exercises. Please complete the if statements so that the field name will not be printed if the field is of type void, which is the 0 bit, which takes up no space at all, which of course is echo. Echo is the void bit. Okay, so echo's the void one. So fields 0. Get the type info of narcissus struct fields. Okay, so this is a structured array. Fields are a slice of the structured field. Crazy that you can do this, by the way. It's crazy that you can, like, I'm operating on struct stuff. I'm not sure why this would be useful. It's just interesting that you could do that. Fields is a slice struct fields. Here's the declaration. Struct field, name, type, default value, is comp time, alignment. Please complete these if statements so that the field will not be printed if the field is of type. Okay, so type. So that means I would go field 0 type does not equal this. Yuck. Look at all that repetitive code above. I don't know about you, but it makes me itchy. Alas, we can't use regular for loop here because fields can only be evaluated at compile time. It seems like we're overdue to learn about this comp time stuff. That's cool. I feel like I run into reflection problems that like that quite a lot when inspecting types in Go, and it's always awkward. Really? I guess I've never ran into that type yet. Even though I did have one point where I could, I just chose not to have it. I feel like a lot of... yeah, I haven't got to any place where I need the reflection yet. All right, so that should build. Inline loop, let's go. Okay, so here we go. So now we're gonna do a compile time loop, hopefully. So this is where things get really interesting. I think this is probably the most interesting thing of it all. This is going to be compile time. Compile time is a program's environment while it is being compiled. In contrast, runtime is the runtime or is the environment while the compiled program is executing. Yep. Errors make an easy example. Compile time error caught by the compiler, usually resulting in a message to the programmer. Runtime error, usually caught by the running program itself or by the host hardware or operating system, could be gracefully caught or handled or could cause the computer to crash or halt and catch fire. All compiled languages must perform a certain amount of logic at compile time in order to analyze the code. Maintain a table of symbols, such as the variable and function names. Optimizing compilers can also figure out how much of a program can be pre-computed or inlined at compile time to make the resulting program more efficient. Smart compilers can even unroll loops, turning their logic into a fast linear sequence of statements at the usually very slight expense of increased size of repeated code. Zig takes these concepts further by making these optimizations an integral part of the language itself. All right, comp time. So this is really cool. So you know with Rust, you can do procedural macros. This is like, as far as I can tell, comp time is like procedural macros. My assumption is not as powerful as procedural macros, but much simpler than procedural macros. Like, you can understand it because you're not stupid. Or you can understand it because you're stupid, and I'm stupid. But the 6 people who can do Rust procedural macros aren't stupid, and they can do that. But that's not you or I. And I don't have a degree in the sin crate. I don't have a bachelor's of science in the sin crate. All numeric literals in Zig are of type comp time int or comp time float. They are of arbitrary size, as big as little as you need. Notice we don't have to specify the size like U8, I32, F64 when we assign identifiers immutably with const. When we use these identifiers in our program, the values are inserted at compile time into the executable code. The identifiers constant and const float doesn't even exist in our compiled application. Okay. So we have these ones. These are just inserted. But sometimes changes when we assign the exact same values to identifiers mutably with var. The literals are still a comptime int and comptime float, but we wish to assign them to identifiers which are mutable at runtime. To be mutable at runtime, these identifiers must refer to an areas of memory. In order to refer to areas of memory, Zig must know exactly how much memory to reserve for these values. Therefore, it follows that we just specify numeric types with specified size. The comptime numbers will be coerced. Okay. So a var int. Okay, here's a var int. Var int. We've reassigned new values here. So, oh, interesting. So it changes at compile time what's going on through here. Bonus. Now we're familiar with the built-ins. Can we inspect the types to see what they are? No guessing is needed. Oh, I need to go like this, right? I assume I have to go. Right, I have to... Oh, did I not get that? Let's see. Variable of comptime int must be const or comptime. I'm confused. Oh, is this var int? Wait, what? Wait, what is it asking for? To be mutable at runtime. I'm super confused at what it's asking to go here. Hold on. Variable of type comptime int. Must be const or comptime. To modify this variable at runtime, it must be given explicit fixed size. Okay, and I'm expected to do what? All right, hold on. Literals are still comptime int and comptime float, but we wish to assign them to identifiers which are mutable at runtime. To be mutable at runtime, these identifiers must also refer to areas of memory. In order to refer to memories, you must have size. Oh, okay, so it's just literally asking me to do like a U32, an F32. Is that what they're asking me to do? Comptime int has no members. Oh. Oh, interesting. U32 has no members? Oh. Wait. Do I just print it out then? I don't like change it. I don't say, hey, print out the type. Comptime int, comptime float, U32. Okay. Okay. I think I understand. I think I understand that now. You can always... you know what? I was doing the wrong thing there. I was doing the wrong thing. Carson's coming in. Yeah, Carson's going to be here. Oh, Carson should be here now. Carson, you want to do this? All right. Well, that was interesting. Okay. I got confused. Yes, but it makes sense. You can't just have a variable that's an integer, that's a var, without assigning its type, because it can't guess the type, because it's not a constant. Okay. Interesting. Oh, come on. That was a great one. That was a great one.